So this video is about a LeetCode problem called container with most water. Okay, so before we move on to discussing the problem and its solution, let me show off a little because like you can see this is the solution. Runtime is 1 millisecond. Now this is just to show that the solution is a good one. You can see like runtime beats 100% of Java submission. So yeah, it is the best there is. Yeah. Now that show off part is done, let's move on to the actual work. And so, what is the problem here? The problem is very simple. You are given an array of integers where each value denotes the height and the index, that is 0, 1, 2, 3, 4. The index of that value is the let's say the position in on x-axis. Okay, so it is very simple. Like we are given 186254837 this array over here. Like as you can see, or if you can't see, I'll just zoom it. So 1 here means that the height is 1, and what will be its x? So it will be 1 because it is the first. Okay, obviously the index will be 0 for 1 here, but since it is the first element, so it will be 1. Second element is 2. It is starting from 1, not 0. But yeah, indexing starts from 0. So take care of that. I forgot that, and for that, because of that, I had to spend a lot more time, little more time. So yeah, remember that. So it is, as we can see, that it is starting from 1 instead of 0. So this is not over here. So yeah, and that will be there. So like second is the 8. So it will be like its x-axis, it will be 2, and y-axis 8. So this point, when we join it with draw a perpendicular to the x-axis, it will get this line from 28 to 20. Exactly, yeah, 28 to 20. So that is what we have to do. And once we have all these lines drawn from these heights, so basically these are just heights, and at what position we have to draw these heights or these lines. So their index plus 1. Like if it is at 0, then it will be at 1. This will be at 2 because index is 1, and 1 plus 1 is 2. So yeah, the position, as you can say. So similarly, the last element, that is 7, where will it be? It will be at height. The if the name of the array is height, then height dot length will give you the position, the actual position on this graph, the position of this height 7. So length will be like 336 and 39. So this will be at 9. X-axis is 9 and height will be 7. So I think you would have understood it pretty clearly by now. If you did not, just see this example and it is not a big deal. You'll understand it. So let's not waste any time. Let's move on to what we have to do. So we have to find the container that can hold the maximum water. So why include the term water here? It is not a requirement. It is a requirement because, like as you can see, this the solution for this case is this one, but the water is will be stored only till the lower height. Like this height is greater, so we might be able to store more water, but it will overflow. Okay, so when we are finding the container that can hold the most water, that is the name of the problem statement and the problem itself. So while finding that, we need to take care of the minimum height, that of the two sides of the container, the one that has the minimum height, that will be the deciding factor, and that will determine how much water it can hold. And by how much water it can hold, what we mean is simply the area. Like you can see, since it is a 2D figure, we do not have any depth here, only height and width. Okay, so we only need to care about two things, the height and the width. So if we want to maximize the area, what is area here? Height into width is the area, as we all know, for a rectangle. So if we want to maximize the area is the amount of water that it is holding. As you can see from the figure, the blue portion is the area inside these two red lines, and that is the amount of water it can hold. So how to maximize the area? Either you maximize the width or you maximize the height. And whenever we say height of the container, we mean the height of the smaller side. Like you can see, this one is bigger, this one is smaller. We only care about the height of the smaller one, because water cannot like stay slant. It will only be straight. Surface will be straight. Okay. So these are the only important things that we need to consider. Now, how do we proceed with it? Okay, so the very simple way to do is the brute force way. How to do one way to do the brute force approach is that simply take this extremities, the last one and the first one, this one, and the last one. Or let me open this and I'll draw you. I'll draw for you. So let's, this is pathetic. Let's just take a brush. I hope you will be able to see. No, this will be clear. Yeah. So the first one and the last one, and find the area between the two. Then keeping the first one intact, go and find it with the second last one, then with the third last one. Okay, so you can do it like that. Then instead of this first one, move on to the second one, and with second one you can take the last, then second last one. So you can find all possible areas, then find the maximum of those areas and print it. So it will just be a nested loop, a for loop inside a for loop, and you will get the answer. But the problem is that that code will not be efficient, and we want efficient code. So what we do, we think, now we have such a problem. What how should we proceed? So my intention here is not to just show you the code. If you want to just see the code, I'll just show you the code. But let me just show. I'll put this code. I've put this code on GitHub, and I'll put the link in the description of the video. So if you want only the code, you can read it over here, take a screenshot, or you can just go to the GitHub page and copy paste the code, whatever you want to do with it. Your decision. The important thing here is how we can approach to such problems, how we can find the solutions. Okay, so what is the correct way of thinking? So what I did here is that we need to find out what we want. What we want is to maximize the area. So we want maximum area, and my handwriting is terrible, but yeah, you get the point. So how do we maximize the area? There are two things that can maximize the area. That is increase the height or increase the width. Okay, height or width. Now, if we want, let's take the highest possible width. How do we get that? So let's take this as the first end of the container and the last one as the second end of the container. So when we take this, we get the maximum possible width. Okay, and we find the area. How do we find the area? Keep in mind, we only consider the height of the smaller side of the container, smaller edge, side, whatever you want to call it. So this will be the actual area we need to consider. The above this portion, that portion is not considered. Okay, so let's have these two as our extremities of the container. We find the area. Now what we do, we need to find if there is other possible areas, like this and this seems pretty high, so it can contain more water than this, or it might not contain, we don't know. So we need to move inwards. Okay, so when we move inwards, we are reducing the width. Okay, because obviously it is the maximum possible width. If we move inwards, the width will reduce. Like for example, if we, instead of the last one, we were to consider the second last one and find the area, now the width is smaller, you can see it, I do not have to explain that. And once we have a smaller width and our target is to increase the area, how do? We have only two factors, height into width, that will give us the area. Now if width is decreasing, the height must increase. Okay, so when we are moving inwards, we need to ensure that the height should be increasing. If the height is not increasing, there is no point in moving inwards. Okay, that is our clue number one. What is our clue number two? The clue number two is as I have said many times since the start of the video, we only need to consider the smaller height. Okay, we only need to like not these two won't be a good example, these two will be a good example. So among these two we can move from the left end. This is the left end, okay, and this is the right end. That was supposed to be in L, okay, yeah. So we can move from the left end, we can move inwards from the right end, okay. But if we move from the left end and we get to this one, okay, let this be the extremity and right one is not moved, so what do we get? We get nothing. We only reduce the width without any increase because the smaller height is the constraint here. It is the bottleneck. Okay. So we have to remove our bottleneck, and for that we can only move from the smaller side. So this is the smaller side, so this must move. Okay, so this is the bigger side, it will stay fixed, the smaller side will move. So when I move inside, I see that the next one is even smaller than the previous one. So will it, in any possible case, can it give me a larger area? No, it cannot. If the height is decreasing, the width is always decreasing because we are moving inwards, and height is also decreasing. Does it give me any benefit? No, it doesn't. So I will obviously never stop on this. So I'll move one step ahead and see. Yeah, the height here is obviously increasing. So I will consider this and calculate the area and then check if this area is greater than what we had earlier. What did we have earlier? So earlier we have, let me go green. And earlier we had this area, this one and this one. Okay, this was our original area. Now we have this red area. So now we will calculate the red area and the green area, and whichever is larger will be stored in the variable. Okay, simple. Yeah. Now once we have done it, we need to move inwards to check for other options as well. And how do we do that? Again, we look at which is the smaller height. This left side is the, it has become too clunky, so let me clean it a bit. Okay, so currently we are here, okay, and here. Now we have to maximize the area, we need more area. And so if we move from the smaller end, then we are getting this possible value of height, okay, because the smaller side should increase. If we are moving from the larger side, as I already mentioned multiple times, we do not gain anything even if this height was a greater one. Let me do a black here. So even if this one was like very high, so instead of moving this one, I moved this one, and I in the new let's say edge is this, and I did not move from the left, and it was this. Do I get any benefit? No. The height is still the minimum only, and it is still unchanged, and the width only decreased. Okay, so we should only move from the side with the lower height. So this one is obviously the lower height, so this one will move, and we come here to this point, and the right side is unchanged, we stay here only. Now we calculate the area that is covered in these two, and then match it with the previous maximum area that we had, and similarly we keep on continuing. So I hope you get the logic, what logic I tried to achieve. Okay, what logic I came up with. Now what we have to do, we have a basic logic. Now we have to actually convert this logic into code. So when you are trying to convert your logic to code, you need to consider all possible scenarios beforehand. Okay, so what are the all possible scenarios? So as we have seen here, we if our initial edges will always be fixed, the first and the last element of the array. Okay, so but when we are trying to move inwards, we can sometimes move from the right end, like if this was the endpoint, or sometimes we can move from the left end, like when the right end became this point, at that moment we had to move from the left end. So the first scenario is we are moving from the left end. The second scenario is we are moving from the right end. And the third scenario, like for example, let us say that in some iteration we have reached a point where our left end is that point and right end is this point. So both are equal in height. Okay. So in that case, where should we move? Okay. So basically we have three situations. The first situation is move from the right side. The second situation is move from the left side. And the third situation is both are equal. So move from which side? So move from both side. Why should we move from both side? That I'll explain later. Okay. So when should we move from the right side? So when we are moving from the right side, like when this thing was smaller, the right end was smaller, then we moved from the right side. Okay, so when we are moving from right side, that means the right is less than the left end. The right edge is less than the left edge. Only then we'll move because we need to increase the height, the minimum height of the two, right and left, whichever is minimum, we need to increase that. So if right is left less than left, so we move the right side inside inwards. Okay. Similarly, if the left is less than the right, then we move the left side inward. That is, this one was smaller, so we moved it in this direction and came to this point. Okay. So second is left less than right, and the last is both are equal. So left and right, both edges are equal. In that case, why do we need to move both? Why can't we move one? Okay. So the thing is, if we move only one, okay, we do not uh, we do not get any benefit from moving one side. So we are not able to see it over here. I'll explain you. Just let me draw some rectangles. Okay. So for example, let there be something on this side. We are not considering that. This yeah. So there are some things on the left and some things on the right. We do not know. But at a certain position, we have reached a point where we have this right and left edges as these two blocks. They are of the same height. Okay. And now we don't know if we should move from the left edge or from the right edge. Where should we move from? So let us like think, let's say this one is larger and this one is even larger, whatever. Yeah. So let's say we move from the left side, or let's say we move from the right side. So if we are moving from the right side, we are gaining some height. Okay. So this becomes our new right edge. Uh, this one becomes our sorry, I need to select the brush. Yeah, this one becomes our new right edge, and this one is still our old left edge because we moved from the right side. So yes, we gain height from the right side, but the left side is still the same, so our actual area is unchanged. Okay. And it is because of the fact that we have discussed it till now, that is, unless and until the smaller height is increased, there is no point of moving inwards. Okay, as simple as that. And when both of the sides are of equal height, then both must increase. Otherwise, there is no point in moving inwards, because even if one is going to increase, the increase will have no effect because the other side is small, so the water cannot fill up up above, like more than the smaller side. Okay. So I think you get the point. So if when both are of the same height, then both have to move inside. That is, we are moving inside from the left side as well as from the right side. Okay. So these are the three scenarios. Now if we want to look into it, we should go into the code. Okay. And when we go into the code, you might get confused a bit, but I would suggest that don't look at the code and try to understand it, understand the logic, and then if you have any problem implementing a particular portion of it, then you can look at the code to get take a reference. But if you try to understand the code, you might get confused a bit because everyone writes code differently. So, but let's try to understand how or what I am doing here. So this is the max area, the actual function. The rest are just helping me to run the actual function. So when we are here, what we get to see is um, I have taken a left index initially that will be 1, not 0. Remember, we are moving from 1. And right index is height dot length because yeah, again we are moving from 1, so the right will be height. So whenever you are calculating the height, getting the value of height, you remember to put a -1 because if you do not, you'll get a array index out of bound exception. Okay. So we have a left index, we have a right index, and then I'm taking two variables. M area here means the maximum area, temp area means the temporary area. Okay, as simple as it could be. Now this calculate area, it will simply calculate and give me the area. Okay, the function you can look into it, nothing, just multiplication and yeah, whatever. We can look into it later. What the important thing here is this while loop. So it's a simple while loop. Whenever you do not know how many times a loop is going to run beforehand, just write while true and start writing the logic inside it. Okay, and things will handle themselves. Okay, so now when we are inside the while loop, we are checking for three conditions. The first is left index is greater than the right. If left side is bigger than right, then what are we going to do? We are going to move left. Okay, when I'm saying move left, I'm actually yeah, you might get confused because of the nomenclature. It is actually move the right edge left towards, okay, towards left. So move towards left, it should actually be move towards left, but I think you get it. So when I say move left, we are actually moving the right edge to left side inwards. Okay, so move left because right is smaller, whichever is smaller, it needs to move. Okay. Now, why declare a function entirely? That also we'll see later. So we move left and then at that point we calculate the area and check if it is greater than the uh, temporary area is the area that we calculate just now, and maximum area is the area that we had. If it is greater than maximum area will be updated. Okay, as simple as that. And initially the maximum area is the one with uh, the first and the last elements. Calculate with the first and the last element the maximum area, that will be our initial maximum area. Then move inside and keep calculating other areas, as simple as that. So this was the first scenario. The second scenario is similar. If a right is greater than left, then move to the right. When I mean move to the right, I am actually saying that we need to move the left edge towards right. That is, we are moving the left edge inwards. Okay. Yeah. So again, it is similar. Move right and then calculate the area. Check if it is greater than maximum area or not. Okay. Now the last one is if both are equal, in that case move the right edge to the left and left edge to right. Okay, so this move right, what does move right do? It moves the left edge towards right, and move left will move the right edge towards left. Okay, simple. Both are moving inside. And then calculate area, check if temporary area is greater than maximum area. Okay, simple. Now why to make a move right move left function separately? Because I mentioned earlier that we need to move only and only if the new height is greater than the height we already have. Okay, so this is some logic that you do not have to worry about. Why did I put minus minus inside? When you are going to write the code yourself, you can write it anyway, and then you'll understand it better when you write it yourself. The important thing is to understand the logic, and the logic is very simple. We are going to like keep moving inwards till we find a height that is greater than our current height. Okay, for example, Let me clear it all. Sorry for the time it took. Yeah, let me get something. S- So for example, this was our initial right edge. Now when we move one step inside, do we get an increase in height? No. So are we going to stop here? No. Then we keep moving inside till we find a height that is greater than this one, and then we will stop. Yeah. So I hope you understand that now. So that exactly is what this while loop is doing. You can do it your own way, and that would be better for you to understand. So once we have got this, what we need to do, we will return the index. I am returning the index. You can return the height also, whatever you like. So yeah, we return the index of the right edge, and because move left means moving the right edge. So yeah, index of the right edge, and similarly we have the move right function, no different. Calculate area is simply calculate the area from the minimum of the two heights. So I'm getting the minimum height, and then I'm calculating the area. Now why I'm using a ternary and why not min max? It's not that I do not understand math.min, math.max, because it is because ternary operators are faster than math.min, math.max. So that is why. Now, yeah, so I think you get the logic and the code overall, and I hope I was able to explain to you how you should approach similar type of problems. And yeah, that is all for this video. Bye.